can't think of much else to discuss with you at the moment, but our presentation tonight is from Mr. David Jehan, the author of two interesting books on those works up in Sydney.
Clyde Engineering Company.
Clyde Engineering, that's the one. Funnily enough, I was looking at them this week and I packed a few of them to some
That's
of our
good.
customers with good taste, you see.
That's good.
Yes, yeah. No, it's both books are really quite spectacular in all the information and the photos in them. It's a great job you've done on them, David.
That's good, mate. Glad you enjoyed it.
Yes. All right, without further ado, I'll hand it over to you, David. Would everybody wave to say hello, David?
Hello all. Yes, okay, so I'll share my screen.
Yep.
Now, I've just got to, yes, here we go. Right, now we should be able to all see that. I'll just get that out of the way. I'm just rearranging my screen from it, that's it. Okay, so tonight, Bill, just wave if you can hear me. Yep, fine, good. So tonight is all about Clyde Engineering, the diesel era. I gave a lecture about a year ago on the steam era. This is on the last part of it. So the steam era was 1898 to 1948. And of course, this is 1948 to the year 2000, which is the last part. I used to work for Clyde as a designer in the 80s. I'm a mechanical engineer. And so this is basically taking you through that latter period with all the diesel electric and diesel hydraulic locomotives. Okay, now I have changed this talk because we are the Light Railway Research Society, and so therefore I'm emphasising the diesel hydraulics, which is the cane fill stuff. So the agenda tonight, I'm going to give you a brief history of the electromotive division of General Motors, the Clyde Engineering General Motors Associate Builders Agreement, which was basically started it all, the production from 1948 to 2000, which includes the 5 generations of diesel electric locomotive and the 5 models of diesel hydraulic locomotive, the 1998 celebrations, and of course post 2000 corporate changes. The electromotive division of General Motors Corporation was basically formed in 1941, and it came together when they'd already acquired the Electromotive Company and also the Winton Engine Company in 1930, but they finally formally merged them into a division of the General Motors Corporation, which of course is mainly an automotive building organisation, and created EMD, the Electromotive Division. Now, the guy who started this all was a bloke called Harold L. Hamilton, who actually started the Electromotive Company, and he was one of the pioneers in electric drives because he'd noticed that all these diesel mechanical things being used in the forests where he was working in the forest railways. Basically, the gearboxes were getting smashed, but he thought if he had an electric drive, it would be able to cope with all those impacts and changes far better than a straight mechanical. Later on, when he formed the EMC company, he took on Dick Dilworth as his chief engineer in 1926. Now, Dilworth was one of those absolute amazing characters in rolling stock design. He was the guy that invented bogie-mounted brakes, took the brake cylinders off the underframe and actually put it onto the bogies. That was his invention, amongst many others, and he was an amazing guy. Picture here in Kansas, I'm just trying to move this thing that stops me from seeing what I need to see. Pictured 1934, it gives you an example of the 2 types of rail cars the EMC company was doing: 600 horsepower petrol electric articulated rail car, and later on a 600 horsepower diesel electric powered rail car, the Zephyr. Now, why did they go from the move from petrol to diesel? Well, at that particular time, you had petrol for about 18 cents a gallon, and then diesel was about 3 cents. So it was a totally economic decision to push over to the diesel side of life. Now I'm in trouble, aren't I? Okay. But what the railroads needed was a diesel electric locomotive to haul their big heavy passenger cars. The American passenger cars were big lumps of things, and they wanted to do that at the same speed as these wonderful little rail cars. So Dilworth rose to the challenge. So what he did is he took on the three biggest steam locomotives on passenger service in the States at the time, which was the New York Central J1, the Burlington S4, and the Milwaukee F6. And he came up with a rather amazingly simple looking solution, which was known as Dilworth's boxcars, which was two 1,800 horsepower locomotives. They both had their own diesel generator sets. And he put two of them together, and that gave him a 3,600 horsepower machine, and then sent that out and loaned it to various railroads, and very soon found that this thing could haul the passenger services at the speed of these articulated rail cars, which of course proved to the railroad business, the railroad operators, that diesel electric was the way to go for passenger locomotion, for passenger work. But the railroads were impressed by the boxcars, but doubted that the new technology would be able to haul freight. Dilworth again rose to the challenge. So he created what is known in the locomotive history as the diesel that did it, number 103, a basically 4-unit, 5,000 horsepower machine. And that's it fresh out of the paint shops out of LaGrange. And basically this locomotive was loaned and did a tour of the States, hauling immense loads of freight, outperforming all the steam, and pretty much proving, especially to those railroads that had a water problem, that were running across the central US, that diesel electric was the way to go. That was the revolution. If you're interested in EMD and Dilworth, and I'd suggest you 2 books by Franklin M. Rick. They're very hard to get hold of now, but the On Time is a history of EMD, and the Dilworth story he wrote as well. Now, watching from Australia was one Raymond Edgar Purves, who was an accountant. He was the head of Clyde Engineering, and he observed the progress that was being made in the States. He was very conscious that the railway systems in Australia were completely exhausted by World War II, and he saw that diesel electric was the solution. And he also realised that the company that had the lion's share of the orders in the States was EMD, and so he then went all out to get a manufacturing agreement, a license with them. He was a businessman, and a very astute one, but he wasn't an engineer, and he knew that, and he realised he needed engineering expertise. So he then managed to acquire the services of Fred Shea, who was probably one of the most profound Australian-born rolling stock engineers. Came from Victorian Railways, ended up being the chief engineer of the South Australian Railways during their Americanisation, so to speak. The three huge classes of steam locomotive they had on the broad gauge. And then after that, he was head of aircraft manufacture during the war, and had come to Clyde while they were building what was the first of the locomotives for China, which was an aid project that got killed off as soon as China became communist. But that meant that Shea became very much to the notice of Purves, who made him an offer he couldn't refuse, and he moved across and became the first engineering director of Clyde Engineering. And about that time, Herbert G. McLean came across from EMD to basically try and identify a builder that they could link with and start manufacturing, start an agreement and get into the Australian market. And of course, between Purves and Fred, the agreement got signed. So it was, the EMD agreement was duly signed, and the Clyde GM locomotive was born. This also meant major changes. When you change from what was, when the Granville Works, which is a suburb of Sydney, was started by Hudson Brothers, it was basically a carriage and wagon building outfit. Under Clyde Engineering, the first 50 years, it became a steam locomotive building factory, really, with 533 machines being built, as well as a lot of repairs and, of course, a lot of other general industry stuff. Um, and then what happened is they decided to embrace diesel electric, which meant that they had to, basically demolish half the plant. And the main thing they did was to build the diesel electric um, erecting shop here, which is this big sawtooth building you can see in the foreground next to the river. Here's an aerial view that probably makes it a bit easier for you. Here's the sawtooth building here, and that was the electrical shop, which used to be the carriage shop, and that's Clyde railway station here, and the Carlingford branch line, which has now been turned into a tramway. And this is Duck River, which now I would call Duck Creek, because there's not exactly, take your canoe down there these days. But in the cooperation with Electromotive meant a lot of improvements were made to the plant and a lot of labour-saving devices. They put in a cupola furnace, a decimer converter, so they actually were making steel, so they cast their own steel bogies. What you see there is a weld positioner, which means that the welder was able to move the weldment that he was working on. It's a big, basically motorized universal joint, and he could move it as many times as he liked, and which meant it went down from, a huge number of crane lifts just to basically putting it on the machine and taking it off. And so the welding could all be done downhand, which is much better for the welder and but certainly for those of you who've done any welding, a better quality. The first model produced, which was the ML1, that's main line 1 for Commonwealth Railways, were known as GM1 to 11. And for those of you who are unfamiliar with diesel electric locomotives, you've got I assume you can all see my cursor, I hope. You've got a diesel engine driving a generator, which then supplies power, in this case, to 4 traction motors. And of course, that's all controlled from the driver's controller through the electrical cabinet. What you can see there is the artist's impression of GM class, plus also the driver's manual that was produced. For the Victorians, sorry, Frank, I know you hate these things, but anyway, ML2, mainline 2, was the second model that was produced, and that was for the Victorian Railways B class. And of course, in this case, it was had 6 axles, and it was the first one to actually have 6 traction motors, and that's the driver's manual for it. And EMD fought hard not to make a double-ended locomotive, but George Brown from Victorian Railways knew what he wanted and was able to convince them to do so. George Brown and Fred Shea spent a lot of time testing the principle of a flexi-coil bogie with 3 traction motors on it, 1 traction motor per axle. And basically what they had, as you can see here on the bottom left, photograph, it's a close-up of one of the bogies, and what it's under is a flat car full of concrete, and they had a diesel electric locomotive attached, and of course the power was going into the generator from that was going into the traction motors of this, and that was connected to this test car, which was instrumented up so that all the vibration, stresses and like in the structure of the bogie could be measured, and that went around all the roughest track they could find in the States to actually assess its performance. The next one, and it was the last time this modelling system was used, which is at the ML3, mainline 3, was for Pakistan, where we built under the Colombo plan 9 locomotives for Pakistan. And Ron Drummond, who supplied a lot of material for this book, actually joined the company during that locomotive build. And any Colombo plan project has that builder's plate on it, whether it be a wagon or a loco or whatever. This meant that we had to start teaching people, Clyde had to start teaching people about diesel electrics. So of course they came up with their own instruction centre, which was rather a clever 1-room affair. If you looked one way, it was the mechanical section, as you can see, with the cutaway 567 engine, a roots blower and various other teaching apparatus. Turn the other way and you had a full electrical control cabinet, traction controller, brake resistors, etc., just to instruct. So half the course, it was a 2-week course. First week was mechanical, second week was electrical. and you got a little badge if you went. And it was a very clever marketing ploy, because what they did is they opened it to any rail authority who wanted to send their people, whether they were buying Clyde or not. But of course, that for those who were tendered from a railway that never bought their stuff, actually started to indoctrinate your staff into buying GM. Their advertising was had a bit of a pincer movement to it. If you see the ad on the left-hand side, you'll see an ad that's very much aimed at drivers, telling them what a comfortable, wonderful cab you've got. It's nothing like what you used to have. You'll have a wonderful time. And then, of course, on the right-hand side ad is very much the accountants and engineers and like who are looking at, well, how much is all this going to cost? How much am I going to save? How much does it cost to maintain? So they operated very much in a bit of a pincer movement in their advertising. Now, the transition from steam to diesel was a major change in technology for the rail industry, but also it was a major change in the role of the company. No longer did the rail authorities design their own locomotives. The chief mechanical engineer could now only issue a specification rather than a full set of manufacturing drawings as done during the steam era, which was basically built to print. The contractor now designed the locomotive and became the design authority. Thus, Clyde Engineering became experts at adapting the big, heavy American traction systems from electromotive division into locomotive designs that met the various local state requirements set out by the various CMEs. And as you all know, the different gauge and loading gauge requirements of all the different states, plus a whole plethora of other differences. But at the same time, the following year in 1949, Raymond Purves restructured the company. And so Clyde Engineering, rather than being the one company, now became a division of Clyde Industries. Clyde Engineering now focused on heavy engineering, buses, rolling stock, etc. Other members of the Clyde group traded in a diverse range of companies. I mean, when I worked for Clyde Engineering, basically his sister companies were people like B&D Roller Door, Ajax Chemicals, Fox Manufacturing, and a whole lot of other very diverse companies. The strategy was diversification and export. So during the steam era, it was Clyde Engineering Company Limited, and during the diesel era, it was the company Proprietary Limited. So the first generation of Clyde GM diesels used the 567 diesel engine, and the designation 567 is the amount of cubic inches compressed in the cylinder. That's where the number 567 comes from. They're available in 6, 8, 12 and 16 cylinders. They were roots blown, in other words, it wasn't a turbocharger. DC generator, DC traction motors, there was about 544 built between 51 and 66. And there's you can see an engine being lowered into an underframe there. With the roots blowers of these things at the end here, what's called naturally aspirated. The Model G and Clyde's modelling system then changed again for their diesel electric locomotives, and it's beautifully described as it works. It's perfect common sense, makes perfect sense unless it doesn't. It's a strange way they did things. But anyway, a G model is a narrow car body with a single cab on it. So that when we put a G on it, that's what we're talking about. So examples of that are the 1400 class for Queensland, which for a G12A, that's basically a G car body with 12-cylinder 567 engine and an A1A bogie arrangement. Contrast that with down the bottom there with the BHP Whyalla locomotives, where they had a G8B and a G12B. So G is the car body, 8 is 8 cylinders, B is a Bobo arrangement. Okay. We also had New Zealand and Victorian T-class were built. We also built 5 locomotives for Hong Kong. As you can see, Hong Kong Station, or Kowloon Station, it was as it was known then, doesn't look like that today. For those of you who know Hong Kong, then of course in light railway circles, the Portland Cement locomotive down at Geelong. Now the A models are the classic bulldog streamlined nose. That's what an A model is in the EMD world. And of course the models here are A16C. A is the car body, 16 cylinders, and C is of course a Coco wheel arrangement. A J is a flat fronted, and this locomotive down here at the bottom here, a 421 class, had a cab at the other end, and hence it was an AJ 16C. you will go slowly insane trying to understand all this. But anyway, that's what Clyde did. So they built the S class for Victoria. The further GM classes from 12 on had 6 traction motors, not 4, and the 42 class here in New South Wales, followed by the 421. Examples of a G8 and a G12, the Queensland Railways 1700 class, and that is GL8C, G being the car body, L being lightweight, 8 cylinders, 6 traction motors, and also the Western Australian Government Railways A class, which was an unusual class. In fact, the first 6 of them that they built had right-hand drive, and then because they'd instituted a dual running between out of Perth going towards Kalgoorlie was basically both narrow gauge and standard gauge, and all the standard gauge was left-hand drive. For the remainder of the build, they swapped everything over, and they were left-hand drive, which would have been a bit of a nightmare for the staff. 49 class in New South Wales, they built 18 of these off, and Queensland Railways 1450, which were I think the first narrow gauge 6 traction motor equipped locomotives. Examples of the G6, not 6-cylinder or 16-cylinder for it, is the J class for Western Australia, and the Kowloon Canton Railway number 59. So you can see that was the only pure export design they did. They would have all the design and drawings came across from Hong Kong, and it just got built to those. So it was a reasonable amount of export done. One of the more interesting ones was down in Victoria, where they built the Y class, and there were 75 of these. These were a G8B, and what was unusual about them is the fact that they basically were using the power bogies out of the old Red Rattlers suburban cars down in Victoria. And that meant that you had to brake with a lot of diesel-electric design convention, because the brake cylinders had to go back onto the underframe, because that's how the bogies work. They work through brake system linkages. And the fuel tank ended up going in front of the cab, as you can see by this very large fuel indicator. So the driver, as he's driving, could see how much fuel he's got. But they also did road vehicles. They did some 345 double-deck bus bodies that were built on imported British chassis between 46 and 53. They also did a total of 248 single-deck buses, again built on British chassis that had come in. Elgin garbage trucks, and assembling Galleon road graders. Now let's talk about diesel hydraulic locomotives. There were 4 models produced, and that was the DHI, Diesel Hydraulic Industrial, and then they changed that designation to DHI 71 because it was the 71 series engine, GM engine. So this was a Detroit diesel was used in them. And there was 80 of these built. These were a totally Australian design, 2-foot, 3-foot gauge, 3-foot 6 and standard gauge. They also developed the DHI 110, which was the 6-cylinder 110 horsepower, 110 range engine. There was only 2 of those built in for Western Australia. And then they decided, as Clyde was wont to do, to completely change the numbering, the model system, and they developed the HG3R, which was H being the body type. H for hydraulic, G the body type, 3 for nominally 300 horsepower, and R for rigid frame. And also the HG6R, which was the same thing, but with nominally 600 horsepower. So looking at those, you have the DHI and the DHI 71. That's the sales brochure from the 50s when it was developed. And of course, this was the first mass-produced diesel hydraulic locomotive to hit the cane fields, and was very much saw the very rapid demise of 2-foot gauge steam on the fields. For those of you who are unfamiliar with what a diesel hydraulic locomotive is, you have a diesel engine driving a hydraulic torque converter, the motion being with a cardan shaft down to this drop box, which then takes the motion down to the side rods, and the motion goes to the wheels through the side rods. That's the standard design of a diesel hydraulic that Clyde used. Here's 2 shots that are a bit unusual. So the left-hand shot is basically an inverted underframe, and you can see the brake rigging by a single cylinder down the bottom of the page. page there, and you can see that we've got basically a single brake shoe on each wheel, very much like an 060 steam locomotive, but without the pistons. The classic gull wing doors, which was a Clyde invention and then later copied by Ian Baldwin. Brilliant way for having access to the whole engine engine compartment when you wanted it. They had a very interesting way of testing it. Basically, what they did is they had a great big drum brake here, and they basically took a power takeoff from the bottom gearbox, which was where you'd have the power takeoff for the side rods, went into this big wheel, and basically you tightened the belt around this wheel. As you can see by here, you'd wind it up and down to whatever pressure you want. It would have smoked like incredibly when they used it, and the engine would basically simulate a load that it was hauling. And that was how the locomotives were tested. As I say, a bit unconventional by today's standard. But they also, although they were building standard locomotives, they also, of course, built some, let's say, diversions away from the standard product. And for the Hambleton Mill, there was a very good article in Light Railways called That Bridge, which is famous in light railway circles here in Australia, whereby you had folding cabs to be able to get under this Queensland Rail Bridge. And of course, you can see that the hat of the driver as he's hanging out of the cab as it's just gone under. And this bottom photo here is the thing on test in Granville. Of course, they built 5 locomotives for the Nauru Phosphate, and also had the infamy of being on a stamp. These were 3-foot gauge machines. And of course, they were chosen by British phosphate commissioners, mainly because they used the General Motors 71 series engine, which was used in all their other equipment. So spare parts weren't a problem. And this was the only standard gauge machine that was built for Utah at St. Mary's. They made the front of the industry press a few times. For their diesel hydraulics, as well as many times for their diesel electrics. The DHI 110, as you can see here, is the sales brochure for it, and it was, of course, the Lakewood Fire Company. The 2 of them were built for them. They had a fairly short service life and then went off to work for Commonwealth Railways. HG3R machines, which was in answer to Commonwealth Engineering taking them on in their market. They had to come up with a more powerful machine, and it's actually 3 of them together. So the first 2 were HG3Rs, the third one's a DHI 71, but if I hadn't told you that, you probably wouldn't notice. They had for whatever reason, they abandoned the gull wing doors on these and just had basically doors opening. They had a very different way of testing these machines, and what they do is they basically put them up on blocks, on stands, and they couple the 2 locomotives drive together, put one into full power and one into full braking, because these had torque-matic braking in the torque converter. And so that was how you would basically prove that it would work, and then you would switch it over so that the other locomotive was going in power, and the other one was in brakes. Now, this coupling 2 locomotives together to effectively fight each other isn't that unusual. For instance, an example of where it's been used was used in a very different application is with the Swiss Locomotive Works, where basically with the new generation steam locomotives that Roger Waller came up with, what now is 30 years ago, you can see the drive shaft here because that's the gearbox on these steam locomotives, and it's direct coupled here. So what you would have is one locomotive is in full steam, the other one is in basically counter pressure braking, because rack steam locomotives basically turn into a compressor when they go down the hill. And you would do that, and then of course when you finish testing one, you switch it over and do the other one. So it's not a totally unique way of doing things. And this was the only HG3R that was done in another gauge, 3'6" gauge for broken or associated smelters. The HG6R, which used a Maybach German engine and gearbox arrangement, there was 6 of those machines, and one was built for the Electricity Trust, which is in the National Railway Museum, sitting here on the left. They did general and heavy engineering still, because when they built the diesel electric erecting shop, it was the biggest industrial shop in the country at that time with two 50-ton cranes. So as you can see, they were doing very large pieces of machinery for the oil refineries, both at Clyde and Kurnell. They did these structures here, and I just would like you to focus on the top of this particular tower that's here, and that very top arrangement, because when you look at it here, it is in the diesel shop being fabricated. And as you can see, it completely dwarfs the locomotives and the coal wagon being built. And it just showed you the size of weldments that were done. The one thing that I have never been able to ascertain is how did they get this thing out of the door? But they did. They also did a very large trailer, 220 odd ton trailer for the BHP Whaler mines for moving the dragline machinery around. So they were doing quite a lot of variety. But I mean, this photo in itself shows you the variety. If you look closely, you've got an oil tanker up the back being manufactured. You've got a diesel hydraulic loco being done. You've got other diesel electric locos there upside down while they're getting all their plumbing done. There's another one over here. So you can see there's a lot of variety of work going on back in those days. They also had done a lot of bridges, and one of the last bridges they did was in '62, the Fig Tree Road Bridge at Lane Cove. So there was big spans were done, fabricated up in the works like this. They also had the license for two types of boiler, water tube and fire tube boilers from the States, package boilers and the like, and that was quite a profitable business for them. They also built quite a lot of, in the early 50s and 60s, built quite a lot of oil tankers, producing one 10,000 gallon tanker a week, which for Australia is quite a production line. They also, just after the war, as an assistance program for one of the German manufacturers, which produced 500 of these open wagons in kits. Clyde got the job of actually assembling these 500 kits that came over from Wagon Fabrik Talbot, and basically it was done as they were building the diesel electric shop. They just put up two sections of it, put a crane in the middle of it, and that's what they used to get that job done, and then kept on building the shed as it went. They also did quite a lot of industrial stuff for Australian Iron and Steel down at Port Kembla, including slag ladles, ingot buggies, and of course coal wagons, and of course they did some coal wagons for New South Wales Railways. So the second generation of Clyde GM locomotives was the 645, again called the 645 because that 645 cubic inches gets compressed in the cylinder. Done in 6, 8, 12, 16 and 20. Turbocharging was introduced at this stage, into Australia at least. AC generator and DC traction motors, and a total of 303 were built. And that's in the new series that they created, which was SD40 series in the States. And there you have one of them just sitting there. Testing was very, very important for the Americans over in EMD, and they had you've seen the other test car. This is the newer one that they had later. And it's funny actually to look at this and to see all this computer equipment in this test car that, probably the technology that's there is less powerful than the laptop I'm using. And I can tell you I'm not using a powerful laptop. How times change. So examples of Generation 2 locomotives was the Western Australian Western Mining L class, which were the first to use basically an alternator instead of a generator. High adhesion bogies, and of course two of them were also built for Camalco's line up at Weipa. And these were a GT26C, which is G is the body type, T is for turbocharged, 26 is 16 cylinders of a 645 engine, C is the Coco wheel arrangement. This is the 422 class, which was a very different design. As you can see, a low fidelity mock-up was built to basically get people used to the fact that the drive was sitting so far up the front. And of course it was built at heights for signal sighting and the like. You can see that the body is, the actual underframe here is the structural part, because there's no Pratt truss or diagonals supporting it. Basically the roof just kept the rain off. And that was the 422 class, which is a pivotal class here in Australia. Um, Followed by the NJ class, which is a very different structure because it was a very lightweight design for Commonwealth Railways, where the car body was very much part of the strength needed for the locomotive because that allowed you to take a lot of weight out of the design because the Central Australian Railway was a very, very lightly laid line on the narrow gauge. This is an example of the last streamlined locomotive class we think built in the world, which was the CL class. There were 17 of these built. And as you can see if you look at the actual car body, you can see all the diagonals and like. It's basically a Pratt truss like a bridge. Very, very much the car body is very much part of the structure. Queensland coal traffic really put the whole thing into overdrive. As you can see, these three locomotives in the centre of a train here with a locotrol wagon. So you've got locomotives at the head of the train, basically controlling these slave units. There was 208 of these machines built in various configurations. GL is G is car body, L is lightweight, 22 is 12-cylinder, C, and then because of Cocoa wheel arrangement, -2 is was the new solid state technology going into the electrical cabinet. They also built one in a light railway point of view for Townsville Harbour Board, which was ST5. And Clyde Engineering, because we had a thing here called the state preference system, which meant that you are more inclined to get a job if you are building locomotives, if you build them in the state. So if to basically satisfy Queensland's requirements, rather than create a big plant, Clyde subcontracted some 360 locomotives over to their rival Comenge, who did the assembly for them. But it was always amusing that what they did is Clyde did have a small plant in Brisbane. They built a siding specially in it so that the first of any class they built would be shunted into this, and the Premier and the rail superintendents and all the big wigs would be wined and dined under the big Clyde emblem, which was the phoenix, or the duck as we used to call it, so that they wouldn't forget who'd supplied it. The demise of English Electric. Basically, I get asked by a lot, why is it that English Electric left the field? Because they were very much Clyde's main competitor in the early days. And basically, the reason is because all the big American firms, the Alco, the GE, the GM, came under the Association of American Railroads, and they come up with a protocol for locomotive control. So it was an 8-notch control with 74 volts as the control voltage. While the Brits, of course, were doing their own thing at 110 volts. They had some electro-pneumatic controllers. They had some of them had 10 notches. There was various. So getting the American locomotive to talk to a British locomotive was nigh on impossible. The only people to achieve this was in the locotrol arrangement, where these two shots are of the one train. So you've got two General Motors powered locomotives at the head, sending a control signal into the locotrol van, which you can see at the end of those three locomotives on the right. And they are basically converting American control signals into British slave signals to allow the English locomotives to follow. And that was a lot of effort for QR. And so in the end, they gave up and just went American. Changes in design. The Victorian locomotives were amazing in the fact that they actually had a single driving station. They used to drive long hood leading. But when they finally, during the X-class build, which you can see the X-class there on the right-hand side, they converted to actually be what was a far more ergonomic way of doing things, to having a left-hand drive with a short hood at the front, which allowed you to be able to see things a lot easier. The last locos built for Victoria were the C class, you can see there at the top, and the N class, which were what was a JT22HC-2, J being the flat-fronted model, T being turbocharged, 22 being a 12-cylinder 645 engine, H being head-end power, because inside this locomotive is another diesel generator set, which is supplying the power for the air conditioning, lighting, etc. in the trains. And that was done for regional Victoria. Westrail DP glass were also done, and they were the last of the vacuum braked locomotives that Clyde ever built, although it wasn't the last vacuum brake locomotive that Western Australia ever had. So decentralisation of manufacturing occurred, and as the state preference system I've described, it basically was the requirement that a large percentage of the work be done in the state that was purchasing it, which meant that locomotive building plants got built all over the country, which was not a good idea. Granville closed in 1972. Sir Raymond Purves died the following year. Then basically manufacturing was decentralised to Brisbane, Bathurst and Adelaide, and with some subcontracting to Comenge. But later on, as privatisation came in, Clyde took over Melbourne, the Melbourne Works, Port Augusta, Dry Creek, Forestfield, but the design always remained at Granville. Locomotive rebuilding. One of the jobs that tends to go under the radar that they performed was rebuilding 90 locomotives for New Zealand. So these locomotives were built by General Motors Canada or General Motors at LaGrange in the States. You can see them on the left-hand side as they were originally designed. And they then rebuilt them into what you can see on the right-hand side, which a lot of them are still in service. This was quite a large job, and you can see the scope of the rebuild out of this bit of publicity, where you can see the rebuilt stuff is in pink, and the new stuff, such as the short hood, the cab, the engine cowling, etc., and some of the piping and the like is all new. But otherwise, they would refurbish engines, refurbish the generators, traction motors, etc. And that's how the New Zealand job was done. It's a great success. If for Australian builds, they rebuilt the Bs into the As, which was to upgrade basically from a 567 engine, 16 cylinder, up to a 12 cylinder 645. Problem with that was trying to upgrade a 30-year-old locomotive from a 1600 horsepower to 2475 horsepower, which meant that a great idea on paper, but unfortunately a 30-year-old underframe and car body has a lot of stress fatigue in it. And of course, they only got to locomotive 11 and out of the 26 and said, this is a bad idea, we need to stop. And so all that traction equipment, the leftover from the order, went and did the N class. It was sort of a good example of you can rebuild a locomotive, but don't try and, make it much more powerful, because basically the structure will probably let you down. Another more successful one was rebuilding some of the T11 of the T class into the P class, which also had a head-end power unit in it for powering these passenger cars for interurban Melbourne. And also this is one proposal that was done for Australian Iron and Steel, which is an English electric loco, which was basically to scrap the top, complete the underframe up, and put in new engine generator, cabs, etc. They didn't take it up, but that's the sort of proposals that Clyde was putting out for all sorts of jobs. Some they won, some they did not. Then we get to the third generation, which is still the 645 engine with an AC generator and DC traction motors, but Super Series wheel slip, which was in America was called the ST50 class. And what they did to get the job over the line was basically Clyde Engineering persuaded EMD to actually convert, to provide the finance and the engine, generator set and equipment to actually convert the last of the 422 class, 422-20, and basically take it back off New South Wales Government Railways and upgrade it to the Super Series technology, and then use it as a demonstrator. And that was a highly successful exercise. It's a great credit to the sales manager who managed to get the cooperation of the Americans, plus the Clyde Industries board to fund it, and plus actually coordinate it with New South Wales Government Railways. And the equipment that was needed for this, so the story goes, which is true, they basically, one of the domestic orders, they got an engine generator set and hid it in the store until the order came through, because in those days EMD's factory was just flat out. To show you the difference and how effective Super Series was, This is that they built 32 Bobo and Coco Super Series demonstrators and used them all over the States. And this is an example of a coal train in the States where you got the 3 locomotives at the head of the train at the top and 3 in the middle. And these 6 Bobo 4-axle machines, Super Series powered, replaced 7 Coco 3-axle, 6 traction motor machines. So you can see you've with 6 much smaller locomotives, you're hauling the same load because Super Series was all about absolutely optimizing wheel creep so that there was no slippage. Hammersley Iron got 5 of these built, which ironically, these were all built in Adelaide, went to service in Hammersley Iron, and now those 5 Australian-built locomotives got sold to the States and they're operating somewhere in America. They also, the Super Series arrangements was the G class in Victoria and the BL class for Australian National, what had been Commonwealth Railways, and of course the 81 class here in New South Wales, which was a very different design. And this is where the modelling numbering system of Clyde Engineering tends to fall off the cliff, because as you can see, those 2 locomotives are a JT 26C-2SS, that's J being the flat front, T for turbocharger, 26 being a 16-cylinder 645, C being Coco wheel arrangement, -2 electric technology SS Super Series. But you can see they're radically different designs, and my favourite is this shot close-up of an 81 class from New South Wales on the left-hand side being coupled to a Victorian G class. The G class has anti-climbers at the front, which are supposed to mesh and stop one locomotive riding over the other. You can see when the Victorian is coupled to the New South Wales, if you're in a smash, all that stuff's useless because it wasn't designed to ever be connected. Such was the state differences in those days under government rule. The 710 engine was the 4th generation that was developed. 710, again, being 710 cubic inches being compressed in the cylinder, 8, 12, 16, 20 cylinder types, turbocharged, microprocessor control, AC traction, AC main generator, DC traction motors, and they built 146 of these. And this was the SD60 and the SD70. It's at this period where General Electric Corporation from the States really caught up with General Motors and started to actually get more orders than General Motors. General Motors had greatly benefited during the war and were technologically and production-wise ahead of everybody. That by the time you get up into the 80s, GE had caught up. In Australia, we saw these as being the DL class for Australian National, and then of course the one-off locomotive for Goldsworthy Mining, and also the AN class locomotives. And the ANs are an interesting example of how production gets affected by external factors, whereby the production schedule of those locomotives actually got held up by the Gulf War because they used in the bogies the same bearings that were being used in the tanks that were being used in the Gulf War. So the American military had hoovered up all the tapered roller bearings, and so they couldn't build a locomotive for a period. In the freight area, in the coal areas of the Hunter Valley, you have the 90 class, which were actually built in Canada, but with a significant amount of Australian design, and the 82 class, which were built in the Southern Highlands. Then the last locomotives that Clyde did for Western Australia were the Q class, which were when they actually introduced their radial bogies, which were basically a design that allowed the wheel sets to actually move into the curve. So your angle of attack between the flanges and the wheels is much shallower, and you don't get all of the resist. You're basically reducing your track resistance, the resistance of the locomotive running around a curve. And they did the standard gauge Q class and the narrow gauge S class for Western Australia when they were assembled over at Forestfield, again as part of the state preference system. I've used the term fidelity for a mock-up. And you can see here's a good example here. On the left-hand side, you've got a low fidelity mock-up, which is for the C class with the X class sitting beside it. Basically an affair made out of a marine ply with a whole lot of post-it notes and bits of plastic and, just mocking up what does the cab going to look like, what are the easy reach zones for the drivers, etc. To what we now see, and this is the Q class mock-up, is basically a very high fidelity machine, such to the point when you sit down in the driver's seat, you are in the locomotive. This is exactly what you are going to get. May not be fully functional, but it's like almost a simulator, and that's when I've used that term fidelity. Locomotive leasing came in 1986 when Electromotive Division leased 100 ST60 locomotives to Burlington Northern through a special purpose company called Oakway, and that was an electric power purchase. It was actually renting for the per kilowatt hour. Now, Australia then adapted that, and that was power by the hour that you see with the Kooragang Island depot up in Newcastle, where there were 5882 class and 3190 class were leased to freight rail through a special purpose company called Motive Power Company. And the agreement was based, rather on kilowatt hours, based on availability, such that there had to be 84 locomotives always available come what may. That allowed the company to have 5 spares, which were basically in maintenance at any one time. And that has worked quite well. Coaching stock. For you Victorian lads, you would know the Victorian Hitachi cars, and they were assembled by Martin and King, which became Clyde Victoria. Also the Trans-Adelaide cars. 50 of those diesel electric rail cars were built down in Campbellfield in Victoria. The Millennium trains here in Sydney, which was a fairly tumultuous, painful contract for the company. These were a 4-car electric sets with double deck, as is all of Sydney stuff is double deck, apart from the new metro. And they built 141 cars, but they were actually delivered after the year 2000, in 2002, and Clyde Engineering had got absorbed into Evans Deakin Industries by then. And this was a single airbag design, was very totally Australian design, which had only ever been used before in Switzerland, but it gives an excellent ride. And has been used on the Waratah sets, which are the A sets, and Sydney Growth trains, which are the B sets. They're very successful. They also were in electric locomotives as well. First of all, in the Clyde Walkers Consortium, which built these locomotives you can see here, which Clyde really their part in the whole consortium was minor. They provide the commissioning depot, they built the electrical cabinets and provided the staff for commissioning, which I was one of them for a little while. But later on, they actually designed and built their own their own electric locomotives, which were done with Hitachi electric equipment. And here where they then played with the model numbers and tried to adapt the Electromotive Division modelling system to a locomotive that never should have had it done. So it was a JAE 30-3B. So J is flat-fronted cab, A is AC, E is electric, 30 is 3,000 kilowatts, I think. Dash 3B it's because it's a tribo, as were all the electric locos in Queensland. And so they built 22 of those machines. And the fifth and last generation was the 710 engine with microprocessor control, AC generator, and AC traction motors. That was the difference. You now had an AC traction motor on the bogies and radial steering bogies. They built 38 of these. That's the test locomotive in EMD colours up the top in the States. And then they built 4 SD60 Mac demonstrators, which were basically highly successful. And they were so successful that, of course, they then got the biggest order in Burlington Northern in the States, which was something like 350 locomotives in one hit. In Australia, we saw these as the 4000 class up in Queensland, and Clyde built the first 38 of those. When it changed, Evans Deakin Industries built more. And so in 1998, we had probably one of the biggest shindigs in the rail industry. And this was 100 years of Clyde and 50 years of the Clyde GM relationship. And what they had was 3801, the very famous steam locomotive, coupled to at least four of the generations, examples of four of the generation GM1 and other locomotives behind it at Central Station. That was open. It was a special dinner that night, which I had the privilege of going to, and then the following day was open to the public, which was very popular on the day. And Electromotive Division basically gave Clyde Engineering a crystal globe to celebrate the 50 years, and a special builder's plate was made. It was quite an occasion. But the Phoenix had to land. So in 2000, Clyde Engineering got merged into Evans Deakin Industries, and is now, we know them as Downer Rail, because Downer swallowed up Evans Deakin. But the clouds of corporate change also came over the States. So in 2005, General Motors decided they didn't want to build locomotives anymore and sold their electromotive division to Greenbrier Equity and Berkshire Partners. In 2010, Greenbrier Equity and Berkshire Partners, who were basically just a holding company, decided to sell off EMD, which had been renamed Electromotive Diesel, to Progress Rail, which of course is Caterpillar. So in 2012, Downer EDI Rail ceased designing and building locomotives in this country. In 2017, basically Downer sold the whole freight side over to Progress Rail. And so that was it. So there is the series of 3 books that Muggins has written, myself has written, Hudson Brothers, which was the start of the Clyde Engineering story, and then the Clyde Steam era and the Clyde Diesel era, which are both the centre and the right-hand side book is available through Light Railways. Thank you.
Right.
Thank you. Most interesting.
Yeah. Any questions for David?
David,
I
that
think
was
that
the
was
most interesting talk. Thank you so much. I really enjoyed that. My interest in railways nowadays is mostly steam, of course, but this was a very enlightening talk about diesel traction, and the fact that you spoke so enthusiastically and knowledgeably about it. It was a very interesting presentation. Thank you very much indeed.
Thank you. I just tried to put it in perspective for you.
Well, thank you for an excellent presentation. It really was an eye-opener. It's a pity I can't see your steam presentation, but maybe one of these days.
I can redo it.
I have a question. David.
Hello, Mr. Scott.
Yes, hello. Good to see you. Thank you very much indeed. That was wonderful. I just have a simple question. You mentioned the different types of diesel engine and the quantities built.
Yeah.
Where were they built?
Where was the engines built?
Those several, well, there were about 500 and something.
Yeah. The actual engines always were built in Lagrange. That basically stayed as the engine manufacturer in the States. Although in latter days Lagrange, which was out of Chicago, stopped manufacturing locomotives, and that got built in London, Ontario, for quite some time.
What the quantities? I think it was what is it? The first model of engine, 500 and something were built.
Yeah.
Surely that's not worldwide, is it?
No. That's not worldwide. That was
You mean built for Australia?
For Australia, yes.
Those
figures. Yes, sorry. I see what you're asking now. Those figures of how many built was how many for Australia.
Okay, because
not worldwide. No.
There would have been thousands.
Thousands of the things. Yes, exactly.
Yeah, that's what I thought. Yeah.
Sorry, no. Sorry if I didn't make that clear.
And I really didn't think that we built engines in Australia. I didn't.
No. The closest we came to it was Clyde had to convert the engines that were fitted to the GM 1 to 11 and the B class in Victoria, had to convert them to a B to a BC. And that was involved, basically, they installed an Ingersoll Rand machine to actually bore out the cylinders and do that was basically engine refurbishment and upgrading. Okay, that was the closest that came to it. And then, of course, like for that New Zealand job I was talking about, basically what happened is they got the engines, the locomotive came across from New Zealand. They'd take the engine out of it, and immediately that engine would go to the States, and they would get a refurbished engine out of the US domestic market, which they used to call a UTEX engine, unit exchange.
Yes.
That's how it was done. No, sorry if I didn't make that clear. Those production figures were for Australia.
Yeah. And of course, the traction motors are a big story, aren't they?
Ah, yes, yes.
Starting with the D29 and all the various enhancements of insulation and other things that, multiplied the power of the traction motors.
Oh, yes, yeah. And of course, they started making them here. It was funny, actually, the impetus with those early locos, especially to make as much here as possible, is because they couldn't get the US dollars.
Yeah. Yes, it's a very wonderful story. Thank you very much.
Thank you.
David, Bill Hanks.
Hello, Bill.
When you first started off there and about the introduction of diesels to replace steam, I think about here in Victoria, where 25 B-class diesels replaced 70 R-classes.
Mm.
Yeah.
Yep.
The availability of the diesel locomotives over the old steamers, it was just couldn't be compared.
Yes, unfortunately, yeah. So they're most certainly not as much fun, but yes, they're the availability of the thing and the preparation time to get them, working, etc., vastly different. Yes, there was no competition.
Yeah. Well, there was a bit of banter between drivers during the wheat season, which was usually a pretty hot time of the year when you had the diesels coming in, and the crews on those would laugh at the blokes that had to still drive steam locos around.
Yes.
Yes.
David,
Sorry.
David, I'm interested in any information you might have or thoughts you might have about the cane field situation. We all know that by the mid-70s, the excellent Clyde designs ceased to be produced, and E.M. Baldwin's were very successful in the market with innovation. But we also know that Clyde was mucking around with ideas for bogie diesels and so forth. So I'm interested to have some understanding as to why it was that Clyde went out of that market. Was it an unwillingness to build bespoke locomotives, or they had other much more profitable lines, or their sales efforts contracted? What thoughts do you have about that story?
Basically, the story there is the decision was made to leave the market because the market no longer wanted a standard machine, and of course you had your DHI 71 or your HG3R were very much a standard machine. And so although Clyde Engineering Queensland kept monitoring the market, I know that David Bailey, you knew of Dave, they kept monitoring the market and they came up with various proposals. But you must always remember that Baldwin's had an advantage over, and it was the reason why Comenge only ever built the one bogie loco for Cattle Creek and then gave up. And the reason really, when you think about it, really was basically costing. It was two reasons. One was cost, because Baldwin's could build cheaper than everybody else, because Baldwin was basically a small, sophisticated backyard operation, and it was the Seventh-day Adventist company. And the reason why that mattered is because the fact that people would actually, if the job was costing more than whatever they quoted, then members of the Baldwin family and the church would finish it for nothing. So you've got a labour force that'll work for nothing to finish the machine. So, and Clyde and Comenge couldn't do that. They were, if you're going to get somebody to work on it, you're going to pay them. And also Frank Baldwin was willing to basically make any adjustment. He would accommodate anybody. Whatever you want, you could have. So that was I know that the service engineer who used to go around all the mills was a bloke called John McLeod Campbell. I used to work with. He was out of Brisbane. And John said, he just got instructed by head office, Granville, to say, that's it, we're leaving the market. I want you to visit all the mills and tell them we're out of it and offer them our spare parts at a discounted rate. So we want to clear the store. We want to, sayonara. We don't want to be involved. I think they'd ridden the wave of the conversion from steam to diesel, and there just wasn't there wasn't the margin in it, and there most certainly wasn't you've got to put a lot of engineering into designing something new, and then the only way to make a profit for a commercial company like Clyde and Comminge is then build a lot of that same thing. And of course, Baldwin's had the ability to actually still make a profit, or at least break even, just on one locomotive, even if it was a totally new design. Clyde could never do that.
Thank you. That's very, very interesting.
Any more questions?
Yeah, David, it's Peter Knife.
Hello, Peter Knight.
Hi. I'd just like to congratulate you, not just on this book, this volume, but on the series. The fact that you've persisted over quite a number of years and maintained a really interesting format and a readable, consistent standard all the way through. It's a massive contribution, not just to Australian railway history, but to Australian engineering history. And for that, you're to be congratulated. So thank you.
Thank you. Thank you. Now, I can remember when the Tulloch family wanted me to do the history of Tullocks, and I had pushed them back and said, no, thanks. And the reason why I got pulled into that was one Bruce McDonald dobbed me in with Barry Tulloch that, this guy will write it. And I was sitting there and I was the bank's engineer on the Waratah double decks, and I realised the only bit to be made in Australia was going to be the cabs. And in the next build of trains, the whole thing was going to be imported from China or India, etc. And I thought, just because people are going to forget that we ever could make anything, I'm going to write down what we did. So that's where Tulloch came from, and then when I got stuck into Hudson, you could have put Hudson Brothers just as a preamble to Clyde, but that's unfair because of what they did, and so it grew from there, and away we went.
Wonderful.
Thank you.
And speaking of Hudson's, David, I note on the cover of the book that you have on this slide here, it says they went for 132 years. They lasted to 1998. But I think the real book only says 1898.
Oh, that must be my my trial copy. Thank you for that. Yes. No, that's wrong. The real book, the real misprint.
Yeah, the real book's right. Yeah.
Yeah, thank you. Oh, you got me worried now.
Well, I think it is.
Says he diving off to his bookshelf.
Yes, that's right. Yes. No, it's all right. It's okay.
1898. Very good.
I picked that off my mock-up. That's what I've done. Thanks for that.
Any more questions?
Oh, yeah. The EMD diesel also appeared in many non-rail applications as diesel electrics in mine dump trucks and also marine fishing boats. Did they come through Clyde, or were those applications coming directly from USA?
They came through another agent. There was another agent that did the marine and the mining side. I can't remember their name now, but no, I can remember when I worked in the service department of Clyde, we got a couple of inquiries from various, it was a couple of marine inquiries actually, and it was very much, we had, no, sorry, can't help you, and fobbed it off to, it was directed to the appropriate sector. No, that was very much, Clyde was just locomotives and only for Australia.
Thank you.
Yeah. David, Bill Hanks again.
Yes.
Yeah. For a brief period, I worked for General Electric, it was in their signalling side of things, but you
yes.
often hear of quite a bit about locos and so forth. And I remember at the time they were pushing a new locomotive that was had AC generators and or alternators and AC motors, and
Yep.
and I remember them saying at the time that going from DC to AC was a bit like going from steam to diesel in the first place. It was just the AC systems were just so much more efficient.
Oh, yes. Yeah. Yep. That's right.
And
Yeah, and that's why all the things you see all the new stuff you see rolling around, because I mean, Ganninon's or UGL is still operating, still building locos, but you like GE also offloaded their locomotive business, and I think it's Wabtec have got it now.
yeah,
And as the EMD side of things is now Caterpillar through Progress Rail.
right.
But yeah, I mean the world has greatly changed. It's in every sense it's changed.
Yeah, yeah. No,
And of course everybody's now beavering away wanting to do battery electric.
yes, yeah, true. I think isn't there a loco up in the Pilbara region that's battery
Yeah.
electric?
Yes, yeah. Twiggy Forrest is very big on wanting to go, and I think some of his dump cars are that as well.
Right.
And you know, there's various moves to go up that direction.
Yeah.
In the UK, we're seeing the introduction of dual and triple mode locomotives, part for the rail delivery group and some for GBRF. GBRF are also importing refurbished EMD 710 power plants from the States because they're rebuilding Class 56s.
All right, okay.
Yeah. Yeah.
Class 50, forgive my ignorance. Class 56 was an original build by
It was built by British Rail
Yeah, I
Engineering.
thought, yeah, that used to be English Electric. Yeah, okay.
Yeah.
I can clearly remember when I worked for
No,
Clyde Engineering.
they actually, I think 56s, I'm open to correction, I think were built at Crewe or
Right.
Doncaster, one of the two.
I can clearly remember when I worked for Clyde. I took time off and I went for a fairly long holiday in the UK. But during that time, I went and I visited the Foster Yeomans depot where the 59s were operating out of.
Down at Muirhead. Yeah.
Yes, and I can clearly remember talking to the fitter who'd been a BR fitter, and I said, "How do you find working on these machines?" And he said, "I love it." He said, "When I used to go home, having pulled apart English electric locomotives, I was always covered in oil." He said, "I can actually work in my short shirt sleeves on these things. They're brilliant."
That brings up one of the things I picked up from visiting loco workshops. Management always preferred the Clyde GMs for economy. The loco men preferred Brand X for riding quality and quietness.
Oh, right.
English Electric you've mentioned.
Yep.
Alco was, of course, the other big competitor in Australia.
That's right.
And but with the English Electrics, whenever you wanted to work, you had to undo each cylinder head one by one.
Yeah.
The EMD diesel whole block came off in one hit, much faster, much easier.
Yes.
Frank Stamford here. David, could you stop screen sharing so that we can see who's talking, please?
Certainly. I shall do that.
I should have mentioned that much earlier.
Stop share. There you go. Sorry.
Right.
Good.
Yeah. There's a lot of people that don't want to be seen, I notice. Yeah, that's all right. Yeah. All right. Any more questions?
Yeah, I've got one.
Go, Frank.
It was actually asked on the chat. I'll just go back to it, but it interests me too. how did DC motors work with AC generators? What sort of rectifiers did they use?
Yeah, that's it. It was I mean, they went to alternators because they realized they'd got to the limit of making DC generators. They were getting it was going to be so big that the thing wouldn't fit in the locomotive. So that's why they had to go to an alternator, which was allowed them to go to a higher generation of power, but a smaller machine, physically machine. And then, of course, that has to go through, some rectification. I'm more mechanical than electrical, but it then got converted to being DC, down to the traction motor.
So they didn't have AC traction motors?
They did in the end. That was generation 5.
Right, okay.
Yeah.
All right.
That's what generation 5 was. Generation 1's the 567 engine. Generation 2 is the 645 engine. Generator 3 is Super Series wheel slip.
Yep.
And generation 5 is generation 4 is the 710 engine. That's right. And generation 4 is the 710 engine. Generation 5 is you're going to AC traction motors.
Yeah. You talk about traction control. That I remember standing beside a Victorian Railways G class when I was working out in the field somewhere, and it was pulling out of a loop somewhere, and it was trying to lift a pretty heavy train, and watch the wheels, and you could see them going click, 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 just cogging around. They'd start to slip a bit, then the power is off, and then they'd start again. Yeah, fascinating to watch it. And I think there was also a ground effect radar there as well.
Right. Yeah, the Super Series had a Doppler radar.
Yeah.
Yeah, it was a Doppler radar that was behind the under number 1 cab, and it basically that's what made it work so well, was the fact that you were getting the true ground speed of the locomotive. And of course that's fantastic, but that has a bit of an Achilles heel. So, for instance, the 2 Achilles heel that they found was when it went through the tunnels that basically had, basically sort of a concrete floor tunnel, it wouldn't reflect off it properly. So the locomotive stopped knowing where it was. And of course, the worst case of that was going across the Hawkesbury River Bridge, where the Doppler radar basically was looking down at the river. And so it didn't know where it was. So that then made it went into manual mode for a while until you got off the other end of the bridge.
Good.
So they ended up in the tunnels, basically, but shoveling ballast into the middle of the track so that the Doppler, the radar had something to reflect off.
Yeah, wonderful. Yeah. Okay, anyone else? No. Okay, David, thank you very much for that presentation. Very informative, thoroughly enjoyable, and just the way you present is very good. Thank you very much for that.
Glad you enjoyed it.
Right, give us a click.
Yes, here.
There you go.
Yep.
All right. Thank you, everyone, for coming along tonight. If that's it, we'll now terminate this Zoom meeting.
Okay. Thank you.
Yes,
Good
thank you, David. Thank you, Bill, for entertaining me early afternoon in London. But thank you very much indeed. I put something on the chat room there. I think what is interesting was this was a talk about diesel locomotives. My generation really respond still to steam, but it's now a high time that diesel traction deserved its credit for the contribution it's made to railways. The Central London branch, the Locomotive Club of Great Britain, this year, because I organise the meetings, has 2 meetings, one on the Western diesel hydraulics, and one on forthcoming in July on the Deltics.
Yeah.
Both of which were iconic locomotives and were worthy successors to the steam locomotives they followed. And I think David's talk tonight, this afternoon, has been fascinating and really helped put the record right. I think it's really brilliant. Thank you very much indeed for your time and trouble. And it's great seeing you all again. Thank you.
Thank you.
All right. Is that it? Good night, all.
See you
Night.
later. Thanks again.